Hello, hello, hello. Good morning, good evening, wherever you are, whenever you are. My name is Mark Borstein. I'm the CTO of Tremolo Security, co-author of Kubernetes and Enterprise Guide Third Edition. I don't know if we're going to get Scott today. My partner in crime, Scott Sorovich, um, my co-author. So he might be tied up, but we're going to have some fun anyway. So we are going to be diving into the fun realm of OPA. So the Open Policy Agent. And on top of that, we're going to talk a little bit about how Kubernetes extends itself using admission controllers. So in past chapters, chapter I think 6 was authentication, and then 7 was authorization. We covered how to protect the API server, right? How to protect certain APIs from different different kinds of attacks, different type of not even attacks so much as just you know mistakes, right? People make mistakes, happens all the time, at least allegedly. I can neither confirm nor deny that I've ever made a mistake before. Whereas then the question becomes, okay, well, RBAC is great for the API, but it's limited, right? Like you can't do things based off of other APIs. So, like as an example, maybe you want to only allow ingress objects to be created in namespaces that have a label to allow it. Can't do that with RBAC unless you like explicitly enumerate each namespace that is allowed to do that. It'd be a lot nicer to have a centralized policy to do that using a label, because then you can just update the labels as you need to rather than having to go change RBAC policies. Much more dynamic. You can't do that with RBAC. Other things you might want to be able to do are maybe limit certain ingress, or excuse me, certain container registries. That's a pretty common one to do with admission controller. That you say, look, we're only going to trust our own registry. We're not going to trust a third-party registry, or like we're not going to trust Docker Hub or GitHub or whatever. So that can't be done with RBAC. It can be done with an admission controller. So admission controllers are a special kind of webhook that Kubernetes uses to give you the opportunity to short circuit a request. Now, some requests don't go through admission controllers. Okay, so the only requests that go through admission controllers are requests to create, delete, update, or edit an object. Reads do not go through admission controllers because you're not creating anything. It's not a full authorization webhook. It's only a, hey, we're making this change to the API server. Is that allowed? And so the first one that a lot of people came to in the industry was a system called OPA, or the Open Policy Agent. Now, the Open Policy Agent, I think that's Scott. Let's see, is he joining? Oh, okay, cool. Sorry. So Scott won't be able to make it. So it's just us today. So Open Policy Agent did not start with Kubernetes. I believe it started with Netflix as a super lightweight policy implementation engine. Now, what's important to understand about OPA versus other kinds of enforcement mechanisms is, one, it's got its own language, Rego, which is quite old. I think it goes back to the 70s. And two, it's also a database. It's not just a policy engine. So, and this is true of most authorization engines, where because they need to make very fast recommendation or very fast decisions. Most policy engines have their own database that you store things in. So where that becomes important with OPA is when we get to the point where we say, okay, well, we're gonna we're excuse me, we're gonna go ahead and start making decisions based on data other than what was in the request, and we'll take a look at what our admission control request looks like. The other aspect of OPA that's interesting is that there are kind of two ways to interact with OPA. You can either interact with OPA as a standalone binary, and you can like set it up so that that's how you interact with it with Kubernetes. And once upon a time, that's what you did. You would set up OPA and you would put your policies into a config map, and that's how OPA would, process it. But it was clunky. It didn't feel very Kubernetes-ish. There was no type checking. You didn't get good feedback loops. There was no auditing. So if pods didn't meet a policy, there was nothing that told you, hey, this running pod is failing a policy, right? It would only work on mission. So Microsoft got together with a bunch of other folks and created a tool called GateKeeper, which is a Kubernetes native way of deploying OPA. And so that's what we're gonna focus on a lot. A really cool thing about GateKeeper is that it not only makes it easier for you to deploy OPA, it gives you audit policies, which are nice. So you can look at, and we'll get into this a bit more in the next chapter, but you can look at running pods and say, oh, well, even though the policy was deployed after the pod was created, we have something that tells us these pods are violating the policy, so we can act on it. Because, with an admission controller, if you create a policy, that policy doesn't get enacted until the thing gets created, right? So if you've got a pod that doesn't work with your policies already running, Kubernetes isn't going to go back and say, okay, let's see if this pod still works. Like you've got to kill the pod and let it get recreated. So there's that too. So yeah, and then I've had some folks ask us, why did we choose OPA for the book and not Caverno? And so Caverno is another admission controller for Kubernetes. Big difference between Caverno and OPA is that Caverno is Kubernetes native. It was built specifically for Kubernetes. It's got a Kubernetes specific configuration language. A lot of kubadmins really like it because it is Kubernetes specific, right? Like you're not sitting there figuring out this new programming language. You're sitting there figuring out something that looks like Kubernetes. And nothing against Caverno. It's a great project. I like OPA for a couple of reasons. One, I'm used to it. Like I've been using OPA for a long time. So both Scott and I have a lot of experience using, building, and running OPA in production. So that was the first reason. Second reason is because OPA is generic, you can use it for other things. So when we get to Istio as an example, in I think it's going to be in chapter 17 when we do this. We're actually going to show how you can use OPA as a custom authorization engine to extend the authorization inside of Istio. So it gives you the ability to use it for things beyond just Kubernetes. So yeah, so that's why we chose OPA. But again, Caverno's great. Same concepts are going to work here. So before we start diving into the labs, a couple of the things to point out. As we get started in the chapter, we actually first start with a discussion on admission controllers. And so when we wrote the first version, let's see, admission controllers went GA in version 1. What's that? No, I don't know what you're doing, Adobe. I think it was 19 was the version of Kubernetes we were on with the first edition, but it was a beta back then. The important thing is coming into this conversation, and we're going to dig into this a little more in the next chapter too when we get into node security, is that you get the payload when you write an admission controller, you get the payload of the object that's coming in. And then you know who created the object. Now that who can be a bit tricky, because if you as a human being ran kube control create pod, then that would be the who, right? But the thing is Kubernetes, you generally don't create pods. You shouldn't be creating pods. You create a deployment or a stateful set. And there's a controller that says, okay, you've created a deployment. Based on that deployment, I'm going to create a replica set. And there's another controller that says, oh, you created a replica set. Well, based on that, I'm going to create pods. So the identity in that case that your admission controller gets is not the identity of the person or system that created the deployment. It's the identity of the controller that created the pod. This is going to be really super important next chapter when we get into node security and we start talking about pod security policies and why pod security policies ultimately got removed from Kubernetes. But just a little flag, remember that one. Oh, and if you're out there in cyber world and you're watching us live, please say hello. We love to talk. We love to answer questions. So we've got that. We talked about admission controllers. So how does OPA work? So I'm going to go ahead and let's move this over here. Should probably just keep 2 versions of this so I don't have to keep moving it. So I'm just going to show off the book here. All right. So here's OPA's very generic architecture. You've got an HTTP listener, you've got a database, and you've got a policy engine. So you've got to have something that puts data in the database. So what data do you want to put in there? So when you're talking about GateKeeper, right? So the kube native system, what you want to put what you end up putting in there is basically a replica of your API server of etcd. You put it's a JSON database, it's a document database, and you put all of your JSON in there. Well, GateKeeper does it. And so that way you say, oh, well, I need to know about namespaces, right? That's one of the most common is I want to know about namespaces so I can check labels. OPA doesn't know about that. You guys sync that into the database. Now, if you have multiple OPA instances running for like high availability, right? Because you want to make sure if the bad thing happens, you're still up and running. That means you need to keep that database, all of those different databases updated. OPA doesn't talk to each other. There's no there's no clustering of OPA databases. It's all just standalone. It also doesn't persist. There's no persistent volume claim. So if the database dies, you got to reload it, right? So you have to have some kind of data controller in place, which is something that GateKeeper is doing. Now, you might ask, well, why doesn't OPA just talk to the API server? It's an API and performance speed, right? Because if it's talking to the API server, that means the API server's got to authenticate it, pull in the information, process it, etc. Whereas if you have a controller keeping the database up to date, then you don't have that problem. Now, the downside to that is that, of course, that data could be out of date. And remember, we're talking about eventual consistency. It's Kubernetes. Now, my favorite meme that I like to post out there, anybody who follows me out on the Blue Skyverse. Blue Skyverse. See, Twitterverse is easier to say. I don't like Twitter. It's easier to say Twitterverse than Blue Skyverse. The sky, maybe that's it. Anyway, eventual consistency is a lie. Why is eventual consistency a lie? Because of webhooks. Because webhooks don't get retried in Kubernetes. So if a webhook fails, it doesn't get tried again. Now, if a webhook fails authorization, sometimes it'll retry. It depends, but it doesn't. It's one of those things that it's not really good and consistent. So that is a risk when it comes to anything that is using replicated data. Is that stale? So that said, you also have a API server, or you have policy decisions that have to get made. So what you need to then do is, you offer up this web server, and then the API server, whenever somebody creates a new object, says, hey, OPA, GateKeeper, is this kosher, right? Can this object get created? And that's what the admission controller webhook process does. Now, there's also a mutator, which we'll talk about a little bit later in the chapter. So let's take a real quick look at the policy language. And the policy language is different than what you're used to if you use like a Java or C# or Python or Go or whatever, right? Typical code when you're doing an authorization is you assume fail, and then if the correct scenario happens, it succeeds, right? So this is some pretty basic code, right? We're going to go through all the containers. If the container has a registry and it starts with the allowed registry, we're good. Otherwise, it fails. Right? Verbose, easy to read. Whereas in Rego, the policy language used by OPA, it's a lot more compact. And this does the same thing, but it's a little bit different, where it says we have a rule. This isn't a function. This is a rule called invalid registry. And this rule is true when you get all of the images, right? So you're looking for anything that's an image, and you want a list of images. So, okay, step back. Almost all Rego policies are, here's the list of all things. Here's the list of things that match. Make sure they're the same. Okay, so here we're saying we want a list of all images where the image starts with the input. Okay, so what we're saying here is we've created a list of OK images, OK registries, and we want to make sure that every image in our pod has one of those registries and create that list. So it's not a iterative language. Hey, there's Kafka. Hello, my friend. Bonjour, my friend. It's not a sequential language in the sense that you're going to debug it line by line, step by step. It's much less verbose. It's much more set based, where it's how do you manipulate sets versus how do you iterate line by line code. The next thing that will often trip people up is that it's a trapdoor, where sorry, Kafka, you showed up a minute late, but it is a great question, and I'll rehash it here. Caverno is Kubernetes native. OPA isn't. So if you are only ever going to work with Kubernetes, then it's much more native experience. Whereas with OPA, because it's generic, you can use it with anything. So when we get to chapter 17, we start doing Istio authorization. We're actually going to use OPA to do custom authorization for Istio too. So with Rego, it's actually more of a trapdoor, where if something succeeds, you're automatically going to exit when you fail, Okay, so OK images generates the list of images. That's true. Count images is not equal to OK images. So is the set of OK images, the number of OK images, the same as the number of total inputs? If that is true, it'll go to the next line. If it is false, it'll exit. Okay. So that makes it a little more interesting because now you have to write your rules to say, okay, if at any line fails, I'm exiting, which means I have to default everything to false, default messages, and only return true, only make sure that the error gets generated when there's an explicit failure, which is a little backwards to the way most people write security code. So now let's get into GateKeeper a little bit. So now we're going to dive into the labs. So the first thing we're going to do is we're going to create a new cluster, which I already have. So let me go ahead, export PS1 gets, all right, kube control, get pods, A. Now, something that is a little bit fun that I ran into yesterday when I was doing this lab, and we'll dive into this a bit as we get into the examples. OPA just released 1.0. And with 1.0, excuse me, with 1.0, there were some syntactical changes and they're breaking. Now, the book uses the version 0 syntax. I am updating it to use the version 1 syntax. However, because GateKeeper still by default uses version 0 syntax, and we'll look at what that looks like, we're going to stay there for now with the version 0 syntax. And I'll show you how to use OPA to test that. So yeah, so we got our pod. So the first thing we're going to do is let's go ahead and deploy GateKeeper. Now, in retrospect, I probably should have done this via Helm chart to make lives easier for everybody, but I didn't. So let's go ahead and deploy GateKeeper. And watch kube control get pods and GateKeeper system. All right, so GateKeeper is now running. So now whenever we create an object, it's going to go to GateKeeper to see if there is or admission controller is going to, webhook is going to get fired to send it to GateKeeper. So now we've got that running. Let's talk a little bit about writing Rego and testing. So one of the other reasons why I really like OPA is while Rego does have kind of a steep learning curve, the thing I like about OPA, one of the things I really like about OPA is OPA allows you to test pretty easily outside Kubernetes, right? Because I know we all talk about pipelines and pipelines are great, but pipelines suck when it comes to feedback. You commit code and you're not getting feedback for like 15, 20 minutes sometimes, depending on how long your pipeline takes to run, how many tests are going and whatnot. So I like to be able to test things locally before I commit. And the nice thing about Rego and OPA is that it has a built-in framework to do that. So you can write your policies locally, test them, make sure they work before it ever touches an API server. And that really gives you a great feedback loop. And so we're going to develop our first OPA policy. So I am on page am I on? 320, developing an OPA policy. And let's take a look at what that policy looks like. Oops. I want to bring this back here. There we go. All right. So I want to, okay. I'm just sharing my screen. All right. So I'm going to go ahead. I'm going to close this. We don't need this open. I'll just move it. Okay, here we go. All right. So I am going to close all this. This is from last week. Don't save. All right. All right. So we're on chapter 11. And you're going to see this pre 1.0. Right now, there's no difference between pre 1.0 and everything else. But once I get this working with 1.0 syntax, this will be the pre 1.0 if you want to go with that. So we're going to go to simple OPA policy, Rego, and let's take a look at here. So this is our test. And we've got it starts off with package name. And we've got this violation rule. So the violation rule says, here's the message, here's the details. Now, this violation rule only fires if there is an invalid registry, right? Because if invalid registry is false, then there's no message to create the invalid registry. So see where it's a little backwards. Usually you would say, if invalid registry return, if invalid registry return false, but really what you want to happen is you want your invalid registry to be false, or if the invalid registry is true, right, then it goes to the next message. If invalid registry is false, then there no error occurs. Whereas typically what you'd say is it a valid registry, not is it in an invalid registry? You can even see me kind of getting tripped up a little bit. It seems Cilium is more popular than Calico in terms of Kate's network adoption. Cilium is definitely getting there. I know Scott originally went with Calico. Scott wrote all of our onboarding stuff, and he went with Calico originally because Calico plus Flannel. So Calico for the policy engine, Flannel for the networking worked a lot better in kind. Maybe by the time that we do the 4th edition, Cilium will be a lot easier to run in kind. But in order for us to get network policies, we decided to go Calico with Flannel because we're running everything in kind. Yeah, so our invalid registry rule says, okay, and this is hard code, and you're not going to want to do this in real life, but we're just showing it off right now. It's an invalid registry if all of our input images, right? So we create a set from our input images, and then do any of the images from that set start with Quay.io. Anything but Quay.io, right? So it's this double negative that screws a lot of people up. I get caught up a lot by it too, which is why it's so important to automate your tests. Then we create our input images from 2 different rules. We have one rule that says, let's look for all spec container image, like let's generate that set. And then let's also look in spec template spec. So if you look at a deployment object, it's spec template for your pod, spec again. So we're looking at both any deployment and at any generic pod. So we're going to show why this can get a little hinky in a second. But that's our basic policy for making sure that we're only accepting images from Quay. So how do we test this? Where did my PDF go? So a little bit of a change from testing. Or from the book, but let's first look at the code. So earlier I said that Rego, or that OPA, has its own internal database, and it's a JSON database. Well, the cool thing is it's easy to replicate that JSON database because it's just JSON. So in our test case, we actually have, this is what the admission controller JSON is going to look like. This is what we get from Kubernetes. And so we can say, all right, with this input, let's go ahead and test it out. And so we have test cases for a deployment that is allowed, a deployment that's not allowed, a pod that's allowed, a pod that's not allowed, a cron job that's allowed, a cron job that's not allowed, right? And we're checking our error messages. So how do we run these tests? And you can see here, actually, I guess you can't. In OPA, whenever you've got a package, you can create another file called _test with your test cases. So that makes it really easy to test. Now, if you have downloaded OPA from the website, OPA version, right? So this is 1.4.2. So this is the latest. Now I'm going to go ahead and run OPA test, and it's going to fail. It's going to be broken. OPA test. So it's complaining here. I don't know how this happened with, it's really annoying. Let's see if I can, I don't really understand. I don't understand what this is or how I got it. I want it to go away. What if I do this? Okay, so this is easier to read. Okay, it's a lot easier to read. Okay, so let's clear this out and do it again. So this failed. Oh, I'm not in the right chapter. Duh. Chapter 11. Simple. CD Rego. All right, let's try this again. So this fails because we don't have the right syntax. In version 1, these rules change a little bit because instead of it being violation and then the block, it's supposed to say violation if. And so that makes it a little bit more readable because now you can see the difference between a rule and a function and variables. So in order to make sure that we don't have this problem, we say OPA, hey, V0 compatibility. So we had 7 out of 8 tests pass. 1 failed. The reason why 1 failed was because cron job not allowed, right? Like it says here, we had a not allowed job fail to run, right? So we failed to stop a cron job that was from a different registry. So let's go ahead and fix that. Go back to our limit here. So we're going to add an additional rule that says, okay, when we construct the input images set, let's include anything that looks like a cron job too. So now when we run it, var images unsafe. What did I break? I broke something. Input. No, that's correct. Oh, because I forgot to remove the if. There we go. Oops. Where'd everybody go? There we are. So now it failed, or now it succeeded, right? 8 out of 8. So now I can take that code and put it into Kubernetes. So that's going to be our next step. So this is what our code will look like. Oops, come over here. So now let's look at the YAML. And there are 2 things that we need to deploy. The first thing we need to deploy is a template. So this is how we tell GateKeeper, hey, I want to have a policy, right? It doesn't actually enforce the policy on anything. It just says, here is a policy. And so it's the exact same thing as before. The only difference is we left this uncommented, right? Because we want to cover everything. But again, we're just hard coding it to Quay.io. So this is the exact same thing. But this is a little nicer than putting it into a config map, right? Because like there's some type safety, there's some type checking. And then I think GateKeeper does something a little ingenious where it takes this and translates it into a CRD. And now this template actually becomes its own type inside of Kubernetes that we can reference. So we're going to go ahead and let's create this. So I'm going to come back here. Where am I? CD chapter 11. Simple. And we're going to go into the YAML directory. Okay, kube control, create F, gatekeeper policy template. Of course, I don't know how to type. Okay, so we created that. Now, here's the cool thing. Kube control get CRDs grep Kate. So it actually created a CRD specifically for our template. So now we reference it as a type in Kubernetes. We actually create, in order to implement this policy, we create an implementation object of the type, just like we create an implementation of a config map or an implementation of a secret, which I think was a really smart way for the Gatekeeper team to do it. So let's take a look at our template implementation. So this is our kind, right? This is our CRD kind that got created. We're going to apply it to pods, everything in the pods, all pod objects. We're also going to apply it to stateful sets and deployments and cron jobs, right? Now, if you're super security minded, you might be looking at this and say, like, why are we applying it to pods, deployments, and cron jobs? Why don't we just deploy it to pods? Now, go back to the conversation we had way back when at the beginning of this chat, of this hour, where we said, okay, if you create a deployment that creates a replica set that creates a pod, well, that means you don't get feedback till it hits pod. So if we create the policy on the deployment, we have a good shot of getting immediate feedback that something broke, right? But we don't lose security because we're still enforcing at the pod level too. So, for instance, if you've got some kind of a trusted rollout provider, a custom rollout provider. So, I don't know if they still do. At one point, Acuity had a custom Argo rollouts, I think they were called, for doing things like blue, green, AB, stuff like that. And this would still work with that, right? Like you wouldn't get immediate feedback, but it would still protect the pod being created. And we're going to apply it to our test policy namespace. So let's go ahead and create that. Create F. All right. Oh, I didn't actually create the namespace, so that would help. Control, create namespace. Oh, wait. What didn't happen here? Oh, yeah. See, I was messing with this yesterday, and I think I see what the problem is. V1 beta 1. There we go. All right. So I got to fix that in the code base. Okay. So we create our policy, right? So now let's go ahead and where'd my Acrobat go? There we go. Let's go ahead and test this out. So I'm going to create the namespace, test policy. I'm on page 325. So now let's go ahead and create the deployment. Actually, I'm going to go ahead and delete this kube control, delete F. Show what happens before and after. So I'm going to create an Nginx deployment. Then I'm going to create the policy. Now I'm going to try and create it with, so here we can see I tried to create a Docker from Docker.io, so it's not from Quay, right? And it worked. Now we apply the policy. Now I try to create something with Docker, and this should fail. And it did, right? Because it's an invalid registry. It was supposed to come from Quay.io, and that's why that failed. And then we can also look at our audit violation. So we've got this running pod right now, right? That is invalid. We created this here, but it's running, right? Because it was created pre-policy. So now, oops. Copy and paste got a little jacked up. I don't know why, because the dash is in there in text. So we can look now that there is an invalid registry pre-policy, right? So that at least gives us something to act on, right? An audit trail of, hey, here's all the violations. So if something snuck through, maybe you've got create on fail as your admission controller policy. Now, big problem with this approach is that it's static, right? We're hard coding for Quay.io, and that doesn't work well. So we want to make it dynamic. So what we're going to do is we're going to update our spec. So that way, we're going to update our spec so that way it actually works with variables. So if we come over here to, where am I? Parameter OPA policy. So if we look at our Rego, a little bit different, where we've taken out the hard-coded, and we're saying, okay, we're going to pass in a parameter now. And if we look at our YAML, and we look at our template, we've now got this section where we're passing in an array of registries. Because you also probably don't want just one registry. You probably need to allow multiple registries. And so we're going to do that here, where instead of it being just one registry, we're allowing multiple registries. And we're referencing that here with this input parameters registries, right? So we're saying, okay, build the set of images that the image matches one or starts with one of the values from the set of registries that we allowed. So a little bit different. So let's go ahead and create that. Is this I might need to delete the old one. Okay. All right, parameter OPA policy, cd YAML, control create F, GateKeeper policy templates. Already exists. That's what I thought. So we're going to delete the old one. Now, because it's a CRD, delete the CRD. All the instances of that CRD also get deleted. So we're creating the one now with the parameter. So if we do kube control get CRDs into grep capes. So there's our CRD, right? Now we're going to create a template for that. So let's go ahead and do kube control create F. Let's take a look at what that looks like real quick here. So here's the policy itself. And this time we have parameters that say, hey, here's what I want. Close more windows. Here's what I want to be the allowed number of registries. And we're saying docker.io nginx this time. But we could totally do quay.io, list them out, our internal registry, our harbor, etc. So let's come back here. And I also want to come over here. So we're going to do kube control, create F, GateKeeper policy, right? So we've created our policy. And now let's go ahead and create an image, a BusyBox image. So because that policy specifically said we could only create images of nginx. If I try and create a BusyBox image, this should fail. And yep, denied the request because it's an invalid registry, right? Now let's go ahead and create one. So this one matches. We're saying, okay, any of them add the nginx registry is okay. And that one got created, right? So we were able to go through and allow the creation. Debugging Rego can be fun because unlike a language like Java, you don't really step through it line by line. You can't debug it. So because it's all based on the way you build sets and set management, you got to think about it that way, is how am I creating my sets and when. You can add debug lines that give you a little bit more information. We talk about that in the chapter. So yeah, inspect code, enforcing ingress policies. Okay, so then we get into, all right, so now we start talking about something that goes beyond RBAC, right? Or something else that goes beyond RBAC in being able to enforce based on labels. This is a really common security practice. It's create a label on the namespace, and then you do an enforcement based on that label. And this is different than user enforcement because you're not saying, hey, only this user can create this thing. You're saying, hey, this namespace is not allowed to have ingresses. Now you could do it via, this is a use case you could do via RBAC if you really wanted to. But that seems like it might be painful. So, because then you got to change that object every single time, and it's a static list, so that doesn't work. Whereas with admission control like OPA, you can say, okay, I'm only going to allow this if the namespace has the label. The trick with this, though, is that if the namespace, how do you know if the namespace has the label? Because the namespace of the object that you're working on doesn't come in with the object in the admission controller payload. It only you have to get that. So in GateKeeper, that's called a cache, and you've got to enable the cache. So the first thing we're going to do is we're going to tell GateKeeper, hey, we want you to go ahead and cache namespaces. Okay, so where am I? I'm going to go up a couple levels. I'm going to go to enforce ingress YAML cat config. Okay, so there's not a lot going on here. This is a config for GateKeeper, right? And we're saying, hey, let's just sync namespaces. You don't want to sync secrets, right? Like that's a big thing, is like you want to be very careful. Don't sync secrets. Never sync secrets, please, ever, 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 ever. There's no security on the open database. None at all. It's just JSON, which is another reason why you should never put anything that is secret or sensitive into an object that is not a secret, right? So yeah, so let's go ahead and create this file. Control create f config. So that tells GateKeeper, hey, we want a sig namespace. So I'll give it a hot second. So then the question becomes, okay, how do we test out our policy here, right? And so we give an example of how to test our policy. And we do that. Let's oops. Go ahead back over here. So if we go to enforce ingress, Rego. So here we have two inputs. Okay. We have our input, which we had before. That is our input from our admission controller. But then if we scroll all the way over here, and with data.inventory as. So this replicates the OPA database. And we show how that's structured in the book. So this way we can control our test cases and automate the tests before we even go to Kubernetes. So we then create our policies. That looks good. So now over here, let's take a look at what our policy looks like. So we say, okay, version 1, right? Same way as your labels are set. Version 1, namespace, the input namespace, the labels, not true, right? So it's missing if allow ingress label is not true. Or, this is important, the label doesn't exist at all. You have to test for both those cases. Really super important. Otherwise, you'll go through a successful policy even if allow ingress isn't specified. Right? So again, it's that double negative that you got to be careful of. So we've created that. So let's go ahead and actually create the let's go ahead and create our policies. So I'm going to come back here. So let's do kube control, create F, GateKeeper template, right? And kube control, create F, our policy. GateKeeper. So we're saying, look, we require this for any ingress object that gets created, right? And then we're going to go ahead and create our namespaces. So if we look at our namespaces that we created, one without an ingress has no label. One with an ingress says allow ingress, true, right? So now that we've done that, let's go ahead and create our ingress objects, see what happens. And I don't know why this doesn't pick up there, but okay, so that failed, right? Because we don't have the allow ingress label. However, we're going to go to the namespace that does have the correct label. Oops. There we go. And it created. So now we have a GateKeeper policy in place that is only allowing namespaces with the correct label to get ingress, right? This is something you can't do with RBAC. Something that requires a little bit of extra work. Yes, you can do this with Caverno, is usually the next question. Absolutely, 100%. So we've talked a lot about stopping things and allowing things to get created. What happens if you want to maybe have some sane defaults? I'm a big fan of sane defaults. I think sane defaults are the right way to do things. I think OpenShift did a really great job with sane defaults around security in a way that a lot of vendors even still don't. Like pod security standards doesn't go with same defaults. Pod security standards just like, we're going to lock it down, and you want to open it up, that's your problem. Whereas OpenShift had some really smart sane defaults where it was like, all right, if you don't specify a Linux user to run as, now I'm not talking about a Kubernetes user, I'm talking about a Linux process user to run as, we're just going to assign a random one for you, right? I think that's a really smart way to go. Security contexts. Again, assign a default and let you override it. Now, this isn't a way to enforce security, right? You still have to have a policy that requires it. However, if you're getting something from a vendor and that vendor doesn't know what user accounts you want processes to run as, same defaults make a lot of sense, right? And I think especially in the enterprise world where, your OpenShift started with, you're trying to implement things that you don't know ahead of time. Those kinds of same defaults make a lot of sense. So we can do that with mutations. So a mutation is not just for teenage turtles that become ninjas and rats in the streets of New York, eat pizza, cowbunga dude. It's also for Kubernetes. Now, you can write mutations in Rego and OPA. It is painful. I mean, like, I'd rather manually manage 1,000 nodes without an API, having to type out passwords, than do it with Rego. It's bad. It's doable. It's difficult. So when GateKeeper did enable support for mutations, they created their own mutation language. So they don't actually use Rego, which I think was a good idea. So we have a lab here. So we're going to create our mutations. So I'm on page 11, or no, that's chapter 11, 335. So I'm going to create my mutation. And I'm going to go ahead and let's create this. And let's see here. So open unison. Again, I don't know why the dashes don't come through, right? Okay. So we created this pod. Now, if we take a look at this pod, control get pod. YAML and test nginx. Test mutations, excuse me. All right. So there is no security context, right? There's no security context at all. So what we're going to say is, you know what, we want to make sure that if a user isn't specified, we want to specify a Linux user account, a UID. So we created this policy, this mutation policy. Where am I? Higher up. Take me higher. All right. Where am I? Default user. Right. All right. So cat add default user. So here's our policy. Not a lot going on here, right? We want to apply it to all pods, except stuff in the kube system namespace, right? We don't want to do stuff in kube system. We're going to assign this random value of 70,391. And we're only going to assign it if it doesn't already exist, right? So if I've already created a user, so like Open Unison runs as user 4 something or other, right? 400 something. I'm not going to override that. But if you haven't specified one because you don't care, then cool. you're going to get one. So let's go ahead and create this. Clear. So just to show there's nothing up my sleeve, right? I'm going to do right. No security context. So now let's go ahead and create that policy. I know we're coming up here on the top of the hour. This is, I believe, the last set of labs. So create the policy. So now I'm going to delete the pod. So it got deleted. Now let's check to see what's going on. Oops. And we're running as user 70,391, right? So we've gone ahead and said, okay, we're good, right? Like this pod now will run as user 70,391, assuming that we don't, we don't already specify a user. Now we want to make sure that the user is not privileged, right? So like here, okay, so first we're going to, okay, I see what we're doing. So to show that this is default, so right now it's 70, 30, 91. So let's update our, so we're going to update our deployment. So instead of it being 703091, it's 19307, right? So we're going to run that same. And see that, okay, our mutator did not overwrite what we wanted, right? So it's the same default. And so we go through here and let's see what else. Spec containers. All right. And this is the last lab. Yeah. Okay. So then finally, one last note. You'll often find that you want to set a value for an object in a list. Okay. So because containers get set, containers are privileged, not pods. That's why. Okay. I was trying to remember why I did this. So I've got an updated policy here. This is our last lab. What did I do? There we go. I'm back. I'm back. Back again. Guess who's back? Tell a friend. All right. So cat set unprivileged. So we're going to want to set unprivileged, but we want every image in a list to be checked, right? So we're going to go ahead and let's see what I do here. So if I do get pods like this, we're going to see there's no security context, right? Right. That's expected. Okay. So now let's create our kube control, create F, set mutate, set unprivileged. Now let's go ahead and delete. Let's run that same code again. And there we go. Clear. Right? Privilege is false. So We've gone through the gambit here. How close am I? Just a couple minutes over, not terrible. We've gone through the gambit here of doing admission controllers. What's this last one? Validating simpler policies. Okay, so there is one last bit that we are going to talk about here. Sorry. So starting in 1.28, Kubernetes added this concept of validating admission policies. So if you don't want to use Kyverno or OPA, you can use CEL, which is a non-Turing complete language that is popping up all over Kubernetes to be able to script stuff. Great little language. So we do have a couple of labs in here. And so this is value admission policy failure true will fail if the namespace is add doesn't have. Oh, okay. So we're going to do the same thing for we're going to do the same thing we did earlier, but with value add policy or validating policies instead of GateKeeper. So the first thing we'll do is let's go ahead and go into enforce ingress YAML. All right, kube control delete f GateKeeper policy template. Right, so that way we're not enforcing there. cd enforce ingress. All right, so very similar to OPA in that there's a template and then there's a actual implementation. The difference here is that for validating, you create your policy, right? And you can see here that this is not as expressive, right? This doesn't give you as much power, but it might be all you need, right? Where for ingresses, if it gets created or updated, I want to make sure that the namespace object has metadata. So this works real well with namespace. It doesn't work with everything, though. So like you can't check CRDs this way real easily. You would still need an admission controller, but they hard code in the namespace object because they know that that's going to be a big one that people want to use. So a lot simpler than GateKeeper. Go ahead, kube control, create F. Okay, so that creates our policy. And then we have to create the binding. And the binding, really simple. We're going to create it to the policy. We want to bind this to the policy. And if the policy triggers, we deny it. Right? Super simple. Control, create F, map, binding. Okay, so now if we go ahead and we try the same test that we did before, but this time we're going to do it with our built-in what the heck is it called? Validation binding, validation admission policies, VAP, right? So it failed not because of GateKeeper, but because of the validation admission policies. And we're going to do the same thing, but this time where it should work. Now, which one of these should you use? I don't like mixing and matching. I find that becomes painful. So my recommendation would be, if you're going to use GateKeeper, use GateKeeper for everything. If you can use VAP, validating admission policies for everything, great. But once you make that graduation to an admission controller, do it for everything, because the mix and match can become really painful. Okay, execute, control, delete, ingress, test, and ns with ingress. See, now it worked. Okay. So yeah, so we covered a lot with OPA and Rego. We looked at how to validate objects as they come in. In our next chapter, in chapter 12, we are going to look at how to protect nodes using this technology. How to design a secure container, what pod security policies used to do, and now that they're gone, how to replace them, and what pod security standards do. So thank you, everybody. If you're enjoying the book, please go to Amazon, leave a review, please. I beg. I don't beg for anything. I beg for this. If you didn't like the book, don't go to Amazon. Scott's going to yell at me for that. But anyway, go ahead and let us know what you think, and hopefully see you next week.